Hello Math Analysis students. In this video we are going to go over the problems on the front of the review homework for the inverse trig unit review. Now before we do that, let's recap really quickly about restricted domains in inverse trig. When we talk about the restricted domains in inverse trig, it means only certain values that our function should be between. So for cosine, our restricted domain for cosine goes from 0 to pi. And our restricted domain for sine and for tangent go from negative pi over 2 to positive pi over 2. And for tangent also goes from negative pi over 2 to pi over 2. Now that means that when we give our answers for these, we are only looking in certain quadrants. For cosine, we can be in the first quadrant or in the second quadrant. Sorry, I said that in the opposite order from which I wrote it in our top two quadrants here. For sine, we can be over here in these to the right of our y-axis. And for tangent, we'll only be to the right of our y-axis. That means none of our answers here for this part will be anything in the third quadrant, and it also means that whenever we are expressing any values that are down here, then we will express these values in negative angles. So we would not want to use 360 for a coterminal angle for 0. This would be 0. This up here would go to positive pi over 2. So over here goes to pi, but down here we're expressing these as negative angles, so this would be expressed as negative pi over 2, and anything in this fourth quadrant would be expressed as a negative angle. So negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2. Also, let's note the notation for these, that you will see things, you will see both this notation, the inverse cosine, and you will also see arc cosine. They mean the same thing. They both mean we're looking for the angle that has the given cosine value, and the same works for sine and for tangent. Inverse sine and arc sine, also inverse tangent and arc tangent. Okay, everything here we will be able to do without needing a calculator. So I am going to kind of rewrite each of these and just go through. You do need to know your unit circle in order to do well on these. For this first one, the arc sine of 0, it's really asking us for what angle. The sine of what angle is 0. So we're looking for the sine is the y value. So what angle has a y value of 0? And of course that angle is 0 degrees or 0 radians. For inverse cosine of 0, it's saying the cosine of what angle is 0. And so that's asking us about the x value. What angle has an x value of 0? And that, of course, is pi over 2. And just going back to these for a moment, for the arc sine of 0, yes, we're talking about the angle that's right here, because these coordinates 1, 0, that would have a sine or y value of 0. And for this, the x value of 0 would be up here at 0, 1 on our unit circle. All right, number 3, the arc tangent of negative 1. It's asking us the tangent of what angle equals negative 1. Since tangent is y over x, if it's going to be negative 1, that means that y and x have to have the same value, but one is positive and the other is negative. That happens in our pi over 4 family. Pi over 4, the tangent is positive 1. So for the tangent to be negative 1, we'd be talking about our angle down here in the fourth quadrant, and that angle is negative pi over 4. Moving on. Next, the inverse sine of negative root 2 over 2. So it's asking us the sine of what angle is negative root 2 over 2. Since sine is our y coordinate, we're looking for what angle has a y coordinate of negative root 2 over 2. That, of course, is our pi over 4 family, and with the y being negative, it's below the x-axis, which is going to put it, we're looking at this angle down here, which is negative pi over 4. For number 5, the arc tangent, square root of 3, it's asking us the tangent of what angle is the square root of 3. And if we know about our unit circle values, then we know that that is going to be pi over 3. For number 6, the arc sine of root 2 over 2 is saying what angle has a sine value of root 2 over 2. Now this is very similar to the one we had over here in number 4, but notice this one's positive. What angle has a y value of positive root 2 over 2? That is pi over 4. And the difference here, the y value being positive is the first quadrant angle for positive pi over 4, and the y value being negative is below our x-axis, so that's why this one is a negative pi over 4. Moving on. Number 7, the cosine of the arc cosine of negative 1/2. So a couple ways we can do this. I'm going to talk first of all about this notation. We have a couple things going on here. So whenever we have multiple grouping symbols, we're going to start from the inside and work our way out. So we're going to evaluate this first, the arc cosine of negative 1/2, and then we're going to take the cosine of that angle. So this is asking us here, the cosine of what angle equals negative 1/2. And so that will be what angle has an x value of negative 1/2, and that would be 2 pi over 3, but then we have to evaluate what is the cosine of 2 pi over 3, and the cosine of 2 pi over 3 is negative 1/2. The other way that you can do this problem, you might realize that cosine and arc cosine are not reciprocals, are inverses of each other. So when you see cosine and arc cosine, they cancel each other out, and our answer is just this part right here, the negative 1/2. Okay, for number 8, the sine of the arc tangent of 8 over 6. Now, if we know our unit circle values, we know that there is no value on the unit circle where the tangent is 8 over 6. That means it is a non-unit circle value, so we need to draw in our triangle. So, arc tangent is positive. We're going to draw this in the first quadrant. Draw in our right triangle in the first quadrant. So right triangle, here's our angle theta here. The arc tangent, that is our opposite over adjacent. So that means our opposite side would be 8, our adjacent side would be 6. And we need to find the hypotenuse right here. That is going to be our missing value or our c value. So we would calculate 6 squared plus 8 squared equals c squared. That's 36 plus 64, which gives us 100 equals c squared. So when we square root both sides, we get that c is square root of 100, which is 10. Now, we go back and we do that last part, which is evaluate what are we finding here. We're finding the sine of this angle, and the sine of that angle, the sine equals the opposite over the hypotenuse, which in this case our opposite is 8, and our hypotenuse is 10. We could simplify this fraction to 4 over 5. Our next problem, the cosine of the arc sine of 12/13. Once again, 12/13, this is not a unit circle value, so this is a non-unit circle value. We need to draw our triangle. Since it is positive, we're going to be working in the first quadrant. Okay, so if the arc sine is 12 over 13, sine is the opposite over the hypotenuse. That means that our opposite side is 12, our hypotenuse is 13. We need to find the missing value right here. This will be our x-coordinate. So we solve x squared plus 12 squared equals 13 squared. 12 squared is 144. 13 squared is 169. We subtract. X squared is 25. So when we square root, we get that x equals 5. First quadrant, so x equals positive 5. And then we are trying to find now the cosine value. And the cosine value is the adjacent over hypotenuse. The adjacent value is 5. The hypotenuse is 13. Moving on. Number 10, the cosecant of the inverse tangent of negative 12/5. Once again, these are not unit circle values, so we need to draw in our triangle. Now we have the tangent is a negative. So that means it's y over x, and that is not a first quadrant angle if the tangent is negative. So this is going to be a fourth quadrant angle. So we'll draw this in right here, right triangle, and there's our angle. Since the tangent is opposite over hypotenuse, our opposite, which is our y value, this is a negative 12, down here in the fourth quadrant. And the adjacent is 5. This is a positive value, positive x value in the fourth quadrant. And we need to find our hypotenuse, which will be our c value. So we'll calculate 5 squared plus negative 12 squared equals c squared. That's 25 plus 144 gives us 169. And the square root of 169 is 13. So our hypotenuse here is 13. We're looking for, now we are looking for the cosecant. And the cosecant is the reciprocal of sine. Cosecant's opposite over hypotenuse. Sine is opposite over hypotenuse. So cosecant is hypotenuse over opposite. Our hypotenuse is 13. Our opposite is negative 12. We don't usually write the 12 in the denominator, so we would normally just write that out front, as this whole expression is negative 13 over 12. For number 11, the sine of the arc cosine of 0. Again, let's do this in parts. Right here, we're looking for what angle has a cosine value of 0. So if the x value is 0, that is going to be pi over 2. And then we're evaluating the sine of pi over 2. The sine is our y-coordinate, which is 1. For number 12, we're doing the sine of the inverse cosine of root 3 over 2. So we're going to evaluate this part first. The inverse cosine of root 3 over 2 is asking what angle has a cosine value of root 3 over 2. Since that's our x value, that is pi over 6. And now we're evaluating the sine of pi over 6, which is 1/2. For number 13, the sine of the inverse tangent of negative 1. So we're going to evaluate this, and then we're going to calculate. The inverse tangent of negative 1 is where our y and x values are equal, but one is positive and the other is negative. I think we already talked about that at one point earlier, and that is negative pi over 4. And then we evaluate what is the sine of negative pi over 4, which is just our y-coordinate, negative root 2 over 2. Number 14, the cotangent of the arctangent of 5/8. So a couple different ways we could do this one. If we know that we're looking for the angle whose tangent is 5/8. Tangent is opposite over adjacent. We could find our missing hypotenuse, and there's nothing wrong with doing that. However, we don't actually need to do that. We know that the opposite is 5, the adjacent is 8. So in the end, when we're asked to find the cotangent is the adjacent over the opposite, so it's just going to be the reciprocal of this 5/8, which is just 8/5. Again, nothing wrong with finding the hypotenuse, but you don't need to do that. For number 15, the cosine of the inverse cosine of 0.3159. Now, we certainly don't know what angle on the unit circle has a cosine of 0.3159. We don't need to do this as a right triangle either, because the cosine and the inverse cosine simply cancel each other out, and our answer that we're left with is 0.3159. For number 16, we're looking for the sine of the arcsine of 1/2 plus the arcsine of root 3 over 2. Now, careful right here. Sometimes students want to cancel out the sine and the arcsine, but we can't, because we have to evaluate all of this part first and then do the sine of that at the end. So we can't just cancel that. We have two parts here that we need to figure out. We're going to figure out the arcsine of 1/2, and we're also going to figure out the arcsine of root 3 over 2. And then we're going to have to add those values together, take the sine. Okay, so the arcsine of 1/2, what angle has a sine value of 1/2? That is pi over 6. And now, what angle has a sine value of square root of 3 over 2? And that is pi over 3. So we need to add these two values together. We need a common denominator, so that would be pi over 6, and we would express pi over 3 as 2 pi over 6. And when we add those together, we get 3 pi over 6, and when we simplify that, we just get pi over 2. So in the end, this whole middle part simplifies to pi over 2, and we're taking the sine value of pi over 2. The sine is the y-coordinate, and so the y value for pi over 2 is 1. And our final answer here, 1. Number 17, we have the cosine of the inverse sine of root 2 over 2 plus pi over 4. So we need to evaluate all of this part first, and then take the cosine of all of that. So in here, there's one thing we need to evaluate, and then we need to add. So we'll have this, and then we'll add to it. Okay, the inverse sine of root 2 over 2 is pi over 4, because pi over 4 has a sine value of root 2 over 2. And then we're going to add our pi over 4. Well, if we add 1 pi over 4 and another pi over 4, we get 2 pi over 4, which is pi over 2. Then we're taking the cosine of pi over 2. Cosine, of course, is our x value, and the x coordinate for pi over 2 is 0. Number 18, the tangent of 3 pi over 4 plus the inverse sine of root 2 over 2. Very similar to what we had before. We want to do all of this. Now within here, there is this 3 pi over 4, and there's this part that we need to evaluate here. And then at the end, we're going to take the tangent of all of that. Okay. So we have 3 pi over 4. And then the inverse sine of root 2 over 2. What angle has a sine value of root 2 over 2? That is pi over 4. Now when we add here, when we add 3 pi over 4 plus 1 pi over 4, we get 4 pi over 4, which is just pi. We're taking the tangent of pi, and the tangent is the y over x. And for pi, our coordinates are -1, 0. So if we do y over x, 0 over -1, then we get that our tangent is 0. For number 19, we are going to take the tangent of all of this stuff here. We're going to evaluate this part. So we're going to evaluate the inverse sine of root 3 over 2, and then add the 2 pi over 3. The inverse sine of root 3 over 2, what angle has a sine value of root 3 over 2? That is pi over 3. And then we add our 2 pi over 3. 1 pi over 3 plus 2 pi over 3 makes 3 pi over 3, which is just pi. And then we're evaluating the tangent of pi, just like we were in problem number 18. The tangent of pi is 0. And for our last one on the front, the cosine of the arc cosine of 1/2 plus the arc sine of root 3 over 2. So again, we are going to be taking the cosine of all of this. We need to calculate all of this. So we'll do the arc cosine of 1/2, find the arc sine of root 3 over 2, and then we'll add them together. So for the arc cosine of 1/2, what angle has a cosine value or x value of 1/2? That is pi over 3. And then for the next part, what angle has a sine value of root 3 over 2? That is also pi over 3. When we add pi over 3 and pi over 3, we get 2 pi over 3. And of course, we are taking the cosine of 2 pi over 3. Cosine is our x coordinate. 2 pi over 3 is in the second quadrant, and so our x coordinate there is -1/2. And that is how to solve all of these problems. Make sure that you know how to do all of these types of problems, because your test will have some that are very simple, some that are multi-step, and some that you have to do Pythagorean theorem.